So here we are in section 4.6, which is on multiplying polynomials. Think about what we've done up to this point. We've added and subtracted polynomials. We've multiplied monomials with monomials. And then we learned how to multiply monomials with polynomials. So now we're ready to multiply polynomials with other polynomials. So our target is to do just that, multiply polynomials, and then to make sure that we simplify our answer in the end. And you know what that means. That means to collect the like terms and to write the terms in descending order according to the degree. So let's try one here. Let's try to multiply the binomial 3x plus 2 with another binomial 4x plus 1. So what I want you to do is I want you to think back to the distributive property, which we learned back in chapter 2. I want you to think of 3x plus 2 as just a single term rather than as a binomial. So think of 3x plus 2, and I'm going to distribute the 3x plus 2 to the 4x plus 1. So if I distribute the 3x2 to the 4x, we get 3x plus 2 times 4x, just like that. And then when I distribute the 3x plus 2 to the 1, you get 3x plus 2 times 1. And now we have to distribute again twice. Here we distribute the 4x, and here we'll distribute the 1, resulting in 12x squared plus 8x plus 3x plus 2. And as we said in our target, what we want to do is make sure that we simplify our polynomial in the end, which means collecting like terms. It looks like we've got an 8x and a 3x that we can combine. And my final simplified answer is 12x squared plus 11x plus 2. So let's try it again. This time, let's multiply a binomial with a trinomial. Let's go with 3x squared minus 2x plus 4. So let's do the same thing we did before. Just think of this 2x minus 1 rather than as a binomial. Just think of it as a single term that we're going to distribute to the trinomial. And when we do that, just like in the previous example, I'll have 2x minus 1 times 3x squared minus 2x minus 1 times 2x plus 2x minus 1 times 4. And now what we'll do is we'll distribute here, here, and here. Now what we get, distributing the 3x squared, I get a 6x cubed minus 3x squared. And because I've got a minus here, I'm going to distribute the 2x but keep the parentheses. 4x squared minus 2x is still in parentheses. And then plus 8x minus 4. Let's now distribute this minus sign, and we'll be ready to collect like terms. I get 6x cubed minus 3x squared minus 4x squared plus 2x plus 8x minus 4. Let's look for like terms here. Those are like, and those are like. So we get down to 6x cubed minus 7x squared plus 10x minus 4. Okay? Now that seems like a pretty tedious process, and it is. But what we can do is we can streamline this. So, for instance, let's take this same example, and let me show you how we can streamline this. So I'm just going to take the same example. 2x minus 1 times 3x squared minus 2x plus 4. So what I'll do is I'm going to take the binomial 2x minus 1, and I'm going to take each term in the binomial and distribute it to the trinomial. So if I distribute that 2x, I get 6x cubed minus 4x squared plus 8x. Then take the second term in the binomial and distribute that to the trinomial. And I get, be careful here with the sign, minus 3x squared plus 2x minus 4. Now let's look to collect like terms here. Those are like. Those are like. And I end up with 6x cubed minus 7x squared plus 10x minus 4. Same answer as the previous method, but more streamlined, more efficient. You're essentially doing the same thing, but you're condensing some of the steps. So I hope that makes sense. Now let's look at our first example where we were multiplying two binomials. 3x plus 2, this is the same example as our first one, times 4x plus 1. Now there are going to be many occasions that you're going to be multiplying two binomials. And from here on out, I'd like you to use this method. I want you to think of the acronym FOIL. And FOIL is an acronym, as I said, where each of the letters represents the first letter of another word. First, outside, inside, and last. Now what do I mean by that? Well, when I say first, take the first terms of each of the binomials. Those are the first terms. Multiply them to get 12x squared. Then take the outside terms of each of the binomials, being on the outside. Multiply them to get plus 3x. Then take the inside terms of each of the binomials, which would be the 2 and the 4x. Multiply them to get plus 8x. And then take the last terms of the binomials, the 2 and the 1, multiply them, and you get plus 2. Collect the like terms, and you get 12x squared plus 11x plus 2. Now I'm going to go back a couple slides to our first example where we multiplied those same two binomials. There it is. 12x squared plus 11x plus 2. Same answer, but again, much more streamlined. Efficient is this FOIL method. Okay? First, outside, inside, last. So you will get very efficient and quick with this FOIL method. The thing is, when you multiply binomials like this, most of the time, the outside and the inside terms, sorry, I didn't mean to do that. The outside and the inside terms, that's the outside term, that's the product of the inside terms. They will be like, and you can combine them, and you might be able to skip this step where you write out the 4 terms and get directly down to the final simplified answer by combining those outside and those inside terms in your head. You might not be ready to do that yet. Let's try another example. Let's try 2x minus 5 times 4x minus 3. And again, let's FOIL. Product of the first terms, 8x squared. Product of the outside terms, minus 6x. Product of the inside terms, minus 20x. Product of the last terms, (15). Combine the like terms again. The outside and the inside terms are like. And I've got 8x squared minus 26x plus 15. Now let's try one in which we can maybe combine the outside and the inside terms in our head and skip a step. Let's try it. Let's try 5x plus 2 times 3x minus 4. Here we go. Product of the first terms, 15x squared. Product of the outside terms, negative 20x. Product of the inside terms, 6x. If I combine negative 20x and positive 6x, you get minus 14x. Product of the last terms, minus 8. So you can skip that step and get directly to your final simplified answer. Now it might take a little bit of practice to get to there, but I would expect you to be able to get there eventually. What if you're asked to take a polynomial, a binomial, and square it? Think about what it means to square something. That means 2 factors of that base. So x plus 2 times x plus 2. Well, now let's FOIL. Product of the first terms, x squared. Product of the outside terms, 2x. Product of the inside terms, 2x. That gives me 4x. Product of the last terms, plus 4. That's how you square a binomial. You can, at this point, just write the base twice and FOIL, just like as we did with the previous examples.